don't know. Zakara, what you think? Because Zakara's in the chat right now. What is it? Yeah. Can you unmute yourself? Or you need me to do it? What's it? Oh, here we go. Zakara, what do you think? What'd you say? Okay, it might be something wrong with her mic. But she actually said that it has low density, right? So remember we said that water that is hot or water that is warmer it's low density because the particles move faster, right? It's lighter and warmer, right? It's lighter and they move faster. So with that being said, when we put the warm water in here, it goes to the top. It moves up, right? So this is the warm water is moving up. It's trying to travel up, okay? But at the top, we have the cold ice cubes that are floating. So because we have the cold ice cubes, we know that cold water increases density, right? We know that cold water is heavier. So when it hits the cold water, it gets cold right here. And because it can't keep going up and the temperature drops, so does the water. The water drops, right? And once it goes back down into the warm water. So the kinetic energy here, it warms that water back up. And then it just makes a cycle, right? It warms it up and it just goes back up. Down, and then it keeps going in a cycle back and forth until it reaches what? What would it reach to end the cycle? Remember the word we talked about when we're talking about when they're equal, when it's no longer hot and it's no longer cold water. When the water's just warm, what has our water reached then? Let's see if anybody just get some bonus points today. You can put that in the chat. What has our water reached then when it's no longer hot or cold? It just keeps cycling. Anybody knows? Yeah, Jaleel, the water is warm water. And what does it reach?
Like, I swear to God.
Make sure it's keep muted, please. So in the essence of time, we're gonna go ahead and move forward, but it actually is until it reaches equilibrium. Okay. So when it equals equilibrium, that is when it is no longer too hot, no longer too cold. The water it's evened out. There's no more. It's not really moving anymore. It stays stagnant, right? So that is how we have that's when the entire thing will be red because it is just equilibrium, right? But until then, the convection currents will continue to rotate in and out until it's done. Okay. So actually took us a little more time than I wanted us to. So we're gonna try and speed through some of this other stuff because this is also just review as we continue. Okay. So let me go back and get my pointer. Okay. So real quick. Yeah, Mr. Bangor Mr. Bangor has made a great point. When we were talking about weather before, that convection current is how we make like tornadoes. That is how we make all severe weather. Is when we have the hot water continually or the hot air going up, cold air going down, and continuing cycling, and that is how we get different types of severe weather, like tornadoes, hurricanes, cyclones, etc. Okay. So real quick in the chat, this is actually very easy. Which one has higher density? Is it the Kool-Aid or the water? Which has higher density? We answered this question 1,000 times. What has higher density, the glass of Kool-Aid or the glass of water? Thank you, Zalia Coachman. Thank you, Zamari. Still waiting for a few more responses. It's just easy. We've been asking this question for like 3 weeks now. Everyone should be able to answer this. Which has a higher density, the Kool-Aid or the water? Thank you, Marley. And exactly. Can I have? Thank you, Kennedy. Thank you. So for those of us who were able to pick the Kool-Aid, that is correct, right? We know the Kool-Aid has higher density because it has a higher solution inside of it, right? Clear water is just regular water, so it won't have as much mass inside of it versus the Kool-Aid has a mass that has been dissolved in it, right? So that is higher density, okay? So quick reminders, when we're talking about density, fluids that are more dense are heavier and they sink to the bottom, right? So this is one of the questions that we're in our do now today, right? So remembering that fluids that are more dense and they're heavier and they sink to the bottom, right? More particles means it is heavier, right? Fluids that are less dense are lighter and they float to the top, which means there's less particles, which means it is lighter, okay? So aside from the measuring density through how much particles are in it, what is the other way we measure how dense something is? What is the other type of density that we look at? We just talked about it when we're looking at the water example. Whether things are what? Who can tell me? We just talked about it. What's the other way that we look at how dense something is? I know we're talking about solutions and things that are in it. But what's the other way we're looking at density? With temperature, right? So Blake, what are some ways that we check density? Or we can change density? I know we can use by adding and removing solution, but it's another way we can change the density of water. Thank you, Justin. Thank you, Marley. Thank you, Zamari. Thank you, Jandia. Thank you, Blake.